Yeah, so I want us to look at some elective math questions, just like we look at the core maths. So this question asks us to integrate from the lower limit a to upper limit b of 3 plus 1 on x power 2. So first of all, I'm just rewriting this side to suit the working. From here, I integrate, I get 3x. I get x squared plus x minus 2 plus 1 all on negative 1 because that becomes the new power. Okay, so this is what I'm getting now. Finally, here becomes 3x minus 1 on x b a. Then because I'm doing integration with the limits of integration given, I substitute giving me 3b minus 1 on b, and then here is minus 3a minus 1 on a, like this. And then from here I expand 3b minus 1 on b minus 3a plus 1 on a. I group like terms 3b minus 3a minus plus 1 on a minus 1 on b, or however you want to put it. Alright, so from here 3b, 3 is LCM over here is ab. As you can see, a goes into this b times, and then b goes here a times, and so I have 3b minus 3a plus b minus a all on a. Now 3 is common here. I have b minus a plus 1 on ab also is common. I have b minus a as well. So since this and this are common, I can have this 3 plus 1 on ab in one bracket, and then b minus ab also in another bracket. And so when I integrate this, the limits of integration given as a, that's the lower limit, and the upper limit b, I get 3 plus 1 on ab times b minus a. Now the second question also has to do with the same integration concept. I think basically all the questions here have to do with integration of, not integration per se, but there's one differentiation here. Yeah, so second question says we should integrate integral from negative 2 to positive 2. Okay, and so we have this, and then the limits has been given and everything now. So just like we did this one, there's no need to change anything from fractional to the negative exponent. So we leave it like that. Go straight forward. Integrate this 3x power 3 all over 3 minus x power 2 all over 2 minus x, which is the new power, and then minus 2 positive 2. And so we have this situation here. Alright, so right from here we try to see if we can cancel some things out. 3 here, x power 3 minus x squared on 2 minus x, from negative 2 to positive 2. That's the limit of integration. Substitution, 2 power 3 minus 2 power 2 on 2 minus 2, all minus 2 power 3 minus 2 minus 2 all power 2 all on 2 minus 2. And then from here we get 8 minus 4 on 2 minus 2, and then again we get minus 8, because have the when you have your power to be an odd number, it will be in a negative form if the number is negative. So you take note. And then here is going to be so positive 4, but because of this it still remains minus 4 on 2, and then this becomes a plus 2. So from here we see this to be 2, so it's going to be 8 minus 2 minus 2 all minus 8 minus 2 plus 2. This away, We have 8 minus 2, that should be 4, and then minus 8, that should be negative 4. And so question 1 and question 2 have been tackled successfully, only if what we did was right. Yeah, only if what we did was right. So we believe question 1 and question 2 have been tackled successfully. And so we quickly go to the last question. Yeah, so we quickly go to the last question for the day. Okay. Yeah, so the last question for the day also reads that we are to find the equation of the tangent. It says we are to find the equation of the tangent. So the equation of the tangent to the parabola y squared is equal to 8x at 2, 4. It's when you hear questions of this nature, find the equation of the tangent to the parabola y squared is equal to 8x at 2, 4, or at any other distance. You should be considering differentiation. And so we differentiate this with respect to x and then y, because it's going to be some sort of implicit or implicit differentiation. There's a way to go about that. And so we differentiate both sides. Now when I differentiate this, I get d, so d dx of y squared is equal to 8x, so d dx of 8x. Now because because here is x, the x will go, leaving the 8 alone. So we have 8 without a dy dx. But here, because it is y and then this is dx, we are going to have 2y still having the dy dx attached to it. So this is something we have to take note of. Now we can make dy dx the subject, which gives us this, and then dy dx is equal to 4 on y. So at the given points 2, 4, at 2, 4, dy dx, if there was any value for x, we would have substituted 2, but because there is no value by that for y, we have 4 on 4, which is equal to 1. And so we now have the gradient, which is m, being equal to 1. And then finding the equation of the parabola, or we use the general form of equation, y minus y1 is equal to m into bracket x minus x1. Y will remain y1 in this particular instance is going to be 4. So we have y minus 4, the m is 1, and then x will remain, x1 is 2, and so this becomes y minus 4 is equal to x minus 2. And so y minus x plus minus 2 is equal to 0. Yeah, or better still, x minus y plus 2 is equal to 0. So this is the equation of the tangent to the parabola at y squared is equal to 8x at 2, 4. Thank you.